In brief answers to the big questions, Stephen Hawking raised a compelling topic. Can we predict the future? Hawking, with his profound grasp of physics, proposed that while science has equipped us to predict some phenomena, there are real boundaries to how far we can see into the future. Quantum mechanics and chaos theory, he argued, make complete predictability impossible, implying a universe governed by randomness and lacking an overarching design or purpose. Today, we'll explore his arguments and analyze whether this randomness truly negates the existence of a higher intelligence behind the universe. Hawking's approach is rooted in two key scientific concepts: determinism and quantum mechanics. Determinism, an idea in classical physics, states that every event or outcome is determined by previous states. According to this perspective, if we know the position and velocity of every particle in the universe, we should theoretically be able to calculate their future positions and velocities, thus predicting the future. However, this worldview faced a challenge with the rise of quantum mechanics, which brought the concept of uncertainty into physics. Quantum mechanics introduced us to the idea that, at the smallest levels of reality, things don't behave in a completely predictable way. The Heisenberg uncertainty principle states that we can't know both the position and momentum of a particle with perfect accuracy at the same time. This principle isn't due to any limitation in our technology, it's a fundamental property of nature. According to Hawking, this means that events on a quantum level are inherently uncertain, which implies that the future cannot be perfectly predicted. In addition, Hawking brought in chaos theory. Chaos theory shows that even in systems governed by classical physics, small changes in initial conditions can lead to drastically different outcomes, a concept famously referred to as the butterfly effect. This means that even tiny uncertainties in the starting point of any complex system, like weather patterns, can result in large, unpredictable changes over time. With quantum mechanics adding randomness at the subatomic level and chaos theory highlighting unpredictability in complex systems, Hawking argued that the future is fundamentally unknowable. This led Hawking to suggest that the universe may be more about randomness than design a place where events simply occur without a guiding intelligence. But does this perspective truly negate the possibility of a higher power or ultimate purpose? Let's analyze this deeper, considering the intricate balance of the universe and how it might actually point to an intentional design. First, let's address the idea of quantum randomness. While it's true that events on a quantum level appear to be random, does that mean the entire universe is without order or purpose? Consider an artist who creates a painting with splashes of color. To the observer, each splash might seem random, but when viewed as a whole, they form a cohesive image. Similarly, randomness at the quantum level doesn't necessarily negate the existence of purpose on a larger scale. Instead, it could be part of an intricate design where microscopic freedom allows for a dynamic, complex universe, one where randomness and order coexist. Then there's the issue of fine-tuning in the universe. Quantum mechanics and chaos theory explain some unpredictability, but they don't account for the precise constants and laws that govern reality as a whole. The laws of physics, such as gravity and electromagnetism, operate with extreme precision. If these constants were even slightly different, life as we know it would be impossible. This fine-tuning suggests that the universe is not simply a random collection of events. It follows a delicate balance that seems designed to support life and complexity. Even with quantum randomness, we observe stable patterns in nature, like the behavior of planets, the cycles of seasons, and biological processes. Such stability allows life to exist and thrive despite the unpredictable behavior on the subatomic level. This balance of stability and freedom could be evidence of an intelligent source behind the design, setting up a universe where randomness allows variety without eliminating purpose. Hawking's arguments also bring us to the question of purpose and consciousness. Why, in a universe supposedly governed by randomness, do humans possess a sense of purpose? Why do we seek meaning, justice, beauty, and truth? If everything were merely random, we would expect humans to function like other organisms, focused solely on survival and reproduction. Yet, we ponder deep questions, seek moral truth, and strive for purpose. This drive suggests that consciousness itself may be more than a mere product of material processes. It may be a reflection of a higher reality. Another critical point is the limitations of human knowledge. Hawking believed that science could explain most phenomena, yet even he acknowledged that absolute predictability is beyond our reach. The unpredictability we observe, the mysteries that science hasn't solved and perhaps cannot solve, may not imply a purposeless universe, but rather reflect our own limits. Imagine a character in a book trying to understand the author's intentions. Their knowledge is limited to what's within their narrative. Similarly, as humans, we may be within a grand design, catching glimpses of order without seeing the full picture. Even chaos theory, which describes the sensitivity of systems to initial conditions, suggests interconnectedness. The butterfly effect shows us that even the smallest elements can have far-reaching consequences, illustrating a universe where every part plays a role, no matter how small. Rather than proving purposelessness, this interconnectedness could indicate a system designed to allow freedom within an overarching structure. A carefully crafted balance of freedom and interdependence suggests a creator who values both order and complexity, allowing for diversity while maintaining coherence. Finally, Hawking's approach, though rooted in scientific reasoning, focuses on the how rather than the why of existence. Science gives us the tools to understand the mechanisms of the universe, the laws and processes that govern it. But science alone doesn't address questions of ultimate meaning, purpose, or ethics. It can explain how particles move, but it can't answer why we should seek justice or what our purpose is in a vast, complex world. So, while Hawking's observations highlight the limits of human prediction and control, they don't negate the idea of a higher intelligence. In fact, these limits could be part of a design that encourages exploration, learning, and wonder. The universe's predictability in some aspects, paired with unpredictability in others, allows humans to exercise free will, make moral choices, and pursue purpose. This blend of randomness and order might be a deliberate design, encouraging growth, curiosity, and the journey toward greater understanding. In summary, while quantum mechanics and chaos theory introduce elements of unpredictability, they do not imply that the universe lacks a guiding intelligence. The finely tuned laws of physics, the delicate balance of randomness and stability, and the human drive for purpose all point to a reality that goes beyond mere material existence. The limitations of prediction may simply reflect our own human boundaries, not the absence of purpose. Ultimately, the universe's order, complexity, and capacity for meaning suggest an intentional design, pointing to a timeless source beyond the constraints of space, time, and matter.